You're welcome to Physics Practical class, and this is going to be my laboratory for today. And what I'm going to do is to perform this experiment, and specifically for the 2025 Physics Practical for number 1, and that is mechanics. All right, so if you look at what Wassce has given to us, from what Wassce has given to us, we are going to predict the kind of experiment that would go with this set of apparatuses or instruments. So if you are ready, I want you to sit down, get ready, get your writing materials. Let's take it one step before the other. All right, I have the diagram, what we are going to do here. But before this diagram, Wassce said we should have a load of mass concealed and labeled P. All right, so I am going to use this paper tape to conceal it, and I'm going to use this mass to label it, P. Then I have a load of mass and then concealed and labeled as Q. That is another one. Then I'm going to have a set of masses of 40, 50, 60, 70, and 80, etc. And these are all the set of masses. And whenever you have your set of mass, it will be recorded on the body. You see maybe 50, 100, as the case may be. And then you have a meter rule, and this is my meter rule. You have a 100 cm piece of string. I have a string. I can get other ones depending on what I want to do. A stopwatch, a helical spring, rotor stand, and a knife edge. This is my knife edge. Now, from what Wassce has given to us, I decided that I'm going to perform 2 experiments. The first one is I'm going to use a meter rule for this. I'm going to use set of masses for number 1 and number 2 and number 3. Then I'm going to use a knife edge for this. And my intention is to carry out this experiment. So for that reason, I can remove this M and call it P. Let me call this one P. All right? Or I can still work with M because I'm going to call it the bigger mass. It's okay, there's no issue. Then, this is my meter rule, and this is the knife edge. So it comes in different designs. So this is the one I'm using. So let's take the experiment one step before the other. I'm going to have that place the meter rule provided on the knife edge and adjust its position until it balances horizontally. Read and record G. So let's do that. This is my meter rule, and this is my knife edge. All right, let's do the balancing. Balance it. Okay, so place my knife edge and my meter rule. I'm going to adjust it. Keep on adjusting according to the instruction. It has balanced horizontally, all right? It has fallen, but don't worry. I will just take my reading. Okay, this is 50.1. It balanced at 50.1. 50.1. So that is what I'm going to use. So my G, capital G, is going to be 50.1 cm. Remember that that's 50.1 cm. Like, that's the issue. Later now, some students will be arguing, but the person that calibrated this meter rule must have made a mistake. So it can fall between 50.1 or even 48 or 52. It doesn't matter. So your own meter rule may have a different reading from this. So that is how we have done for that number 1. Then they say find G. I have found my G. It said keep knife edge at G throughout. That means at 50.1 in the meter rule, my experiment is going to hang there throughout my experiment. All right, so the next one is say M is 30. Adjust its position until it balances. So what I'm going to do right now is, remember, this is 25, and that is for M, and that 25 is at a point P. So what I'm going to do now is to have my own particular mass called M, and I'm going to label it as M. Okay, so I am going to use my going to use this. So I'm going to label this my own as M. Can also be as P. Concealed. All right, so I'm going to call it M. All right, so I'm going to put it at 25 cm. So I'm going to go to 25 cm and tie it. And I'm going to be using this place so that I can hang it well. And because remember, it will be throughout according to the instruction. At 25. So at this place, 25 cm, I'm going to label this, place it there. Okay, so I'm going to tight it here with this paper tape. So that it will be there at 25 throughout. Okay. All right, so the next thing is use 30. So this is 10. This is 10 gram. Okay, this is 20 gram. If you can see this one as 20 gram, then I have my 10 gram. 10 plus 20 is 30. So I will slot it through this place. It will enter. So, and that is going to be my 30 gram. All right, so I am also going to, but this time, I am going to be adjusting that 30 to find my main balance at R. So what I mean is that this particular position, this particular R will be having different position. It's not going to be fixed like this 25. All right, so I'm tightening it here. All right. So I'm going to put it in such a way that the position can be adjusted. I can be adjusting it. All right, so this is going to, all right, let's start what we are going to do. So what I'm going to do now is, I have to find my D, remember? So I have 50.1 and this is 21. So 50 minus 25 is going to give me 25, but this is 50.1, is going to be 25.1. Therefore my D, let me be recording here, my D is equal to 25.1 cm. That is from here to the place the knife edge is placed. All right, so initially I have to change this M because it was not recorded what the value of M should be. So what I did was to, when I checked with 100 gram, it 30 gram couldn't balance it. So I decided to go for 50. I would have also changed this value to 40, but I decided to change this to 50. All right, so let's continue. Remember, all we need to do is to make sure we reduce error. So what I will do now is go back, place it at 50.1, and adjust this place. I'll be adjusting this place until let it be at rest. All right, we have gotten our first point. So this is at 87, it should be at 87.2, and this is at 50.1, 87.1. Let me take 87.1, 87.1. So my first record in this R is at 87.1. So R at 87.1. Then G is at 50.1. But remember, we are looking for the small d. So in order to get the small d, we are going to subtract them. This is going to be 0 point. This is going to be 7. This is going to be 3. Therefore, my d is 37.0. So let's take our table. What is our table going to look like? I'm going to have small m in gram. This is how your table should look like. I mean, this is what we tell our students, and 100% every year with multiple A's. So the next thing is, I think I'll have to take D because I'll take this small d in cm. Remember, I'm not just writing the quantity, I'm also writing the unit I am using to measure it. So this is D. Then remember, the next thing they say, I should evaluate D inverse. So this is going to be D inverse, which is also cm inverse. I don't have to include where is R, where is P, because this D is constant, and I've already recorded it here, 25.1 is constant, and G is also 50.1 cm. It's also recorded there. So I don't have to be bringing R. I'll be doing the analysis here, and I do recording. So the first one is 30.0. Under D is what? 37.0 cm. Then D inverse, I will need calculator for this. D inverse is going to be 1 over 37. But before then, we are going to put them. But let's finish recording the table. So let's go to the next one. So what I'm going to do now is, in the next one, is I'm going to remove 10. I'm going to remove this 10. All right? And go for 40. So I'm going to have 40.0. I'm going for 50.0. I'm going for 60.0. I'm going for 70.0 and probably 80.0. So let's take about 4. This kind of experiment, you can even do a lot of tricks if you like, if you are very knowledgeable about it. All right, let's go for 40. So for me to get 40, I will pick 20. So this is 20. This is my 20. So this 20 plus this 20 is going to give me the required 40. So and there is a way you slot it. I could remember one of my students asking me, how do you slot it? There is a gap in the mass hanger. That is for those of you using mass hanger. And there is a gap in the mass. You just put it that way. It quickly enters. All right. So let's go for the second one. I will still keep, according to this instruction, I'll still keep this one at 50.1. and I will adjust this. Okay, let me. Stress freely, it balances. Okay, that is 77.6. This is 77.5. This is 77.6. So I'll keep it at 77.6. That is my own reading, 77.6. So 77.6 here, 0.6 is going to be 77.6. This is going to be 0.5. This is going to be 7, 2. So this is 27.5. Okay, let me use 2 decimal places here. Remember, if I'm going for 2 decimal places, everything must be in 2 decimal places. This one, I'll go with 3 decimal places or 4 decimal places. All right, let's go for the next one, which is, I'm going for 60. How do I get 60? I will pick my 50 and I'll have my 10. Now, go back to this place. Okay. All right, let me check. Since I'm looking for 50, I'll go with this hanger. The hanger is 50. I'm going to neglect the mass of the hanger, actually. But a very good workman will ensure that both of them will add up to. So, looking for 50, 20. Okay, what I will do is, let me still continue with this one. I will just add a few other ones to get my 50. Okay, so since I have 20 here already, 20 plus, okay, 20, 20, 10. All right. Okay, let's go back. I'm going to keep it at 50.1 as usual. 50.1, don't allow this to dangle. One of the precautions, ensure I avoided error due to parallax when reading the meter rule. I avoided error due to parallax when reading the meter rule. (72.4). 72.4. It's not up to 72.5. 72.4. So this is 72.4. 72.4 minus this is going to be 3. This is going to be 2. And this is going to be, so 22.3. So this is 22.3. So you see, there is understanding here. The values are reducing, okay? So what is reducing? What is reducing is actually, remember this is moment of force. The clockwise moment from where R is hung, in order to balance this weight, the value is reducing, coming this place. So it is continuous going to be reducing in order to achieve that. Okay, so the next one is going to be 60. I will remove the 10 and put another 20. So let's go quickly. Still maintain, you must maintain your G. Oh. I can even detect where I should be going to. That one was almost 10. This is, okay, so. balance horizontally before you take your reading. All right. I ensure that the meter rule and the system balance horizontally before taking my reading. Second precaution, 68.6. Let me just take it that one because 68.6, not 5. I won't take 5. 68.6. 68.6. 68.6 minus 50.1. This is going to be 5. This is going to be 8. And this is going to be 1. So having 18.50. So let's go to 70. All right. Okay. So 66. I'm giving this one 66 at the point. 50.1, 66. So I'm taking 66. So this is going to be 66.0. So at that point, so this is going to be 10. 9 is going to be here. This is 10, remaining 5 here. So this is going to be 5. Yeah, this is going to be 15.9. 15.90. So I think you've done enough. So these are the values we're going to have. Okay, so it was clear and pure because there was an understanding. There was this value keep on going down. So a situation whereby you have 37, 1 up, 1 down, then you know that there is a problem, but this is uniformity, which was correct. So whenever you are giving inverse for WAEC, whenever you are giving inverse of a value, always go for 3 decimal places or 4. But let's go for 3 decimal places. Okay, let me go for 4. So I'm going to have 1 divide 37. The first one, which is going to be 0.120270. I'm going for 4 decimal places. So this is going to be 1 divide 27.5, which is going to be 0.0364. I'm rounding it off to 4 decimal places. So this is 1 divided by 22.3. And this is going to be 0.44, okay, 8. Then the other one is 1 divided by 18.5. And this is 0.054. After the 4, that is 1. And this is 1 divided by 15.9. And that is 0.0629. All right, class, that is the values we have. The next thing we are supposed to do now is to plot the graph. When we are plotting, to plot a graph of M against the inverse. Let me do one last analysis. Let me to tell you what you are going to have when you plot your graph. So let me explain it. to here. When you plot your graph, what you're going to have. Now, remember that from here to here, there is something we call conditions for a body to be on equilibrium, because this is a body being under equilibrium under the condition of parallel coplanar forces. So M times D, that is MD, is the moment, is the anti-clockwise moment, because this is going to be anti-clockwise. If this thing rotates this way to fall down, it's going to be anti-clockwise moment. It's going to be equal to this side, which is clockwise moment, which is M small d. All right. Now, we are now going to plot a graph of minus d. So if I'm going to say that this is going to be MD, which is equal to, let me call it P, and this P is going to be my moment of force. Therefore, I'm going to say that this P is equal to MD. All right. So when they decided to plot with inverse, I'm going to write this one and say P is equal to M dot 1 over D. So that simply means PD is equal to M. Okay, see? Now, if I plot a graph of M against D, my slope is going to be the moment of force. So how do I know the moment of force? The moment of force is simple. The value I put as M, which is 50 in this case, times the distance from here to here. So what is that moment? So the slope you're going to have when you plot this graph is going to be 50 divided by 1,000 to convert it to kilogram, multiplied by from here to here, which is 25.1 divided by 100 to convert it to meter. So if you do this will cancel this. Let me tell you the value you are going to have if you plot this graph. So this is going to be 0.005 times 25.1 divided by 10. So the value of your slope is likely going to be 0.01255. That is the value you are going to have, because the main thing you are going to find here is moment of force. Thank you for being part of this class. Always remember to hit the subscribe button, like this video, and share it. Have a nice day.